All right, hi everybody. We're going to do the part 2 lab. So basically, the purpose of Ohm's Law lab is to look at ohmic versus non-ohmic devices. So we want to see if a light bulb, like this little dude right here, is an ohmic or a non-ohmic device. So this gray thing that you can't quite see right here is actually a variable voltage source. It goes up to 6 volts, so let's just crank it all the way up at some point. This is my ammeter. I know it's kind of hard to see the numbers on your screen, but this is the ammeter and this is the voltmeter. So we're going to take both readings. I'm going to keep track of them in my notebook, which is over to the side. You can see it a little bit right here. So I'm going to keep track of these in my notebooks. I'm going to get a new fresh page. I'm going to make a save table because this is science. All right. Cool. So we've got voltage and we've got current. So remember, the units for voltage are in volts. Current is in amps. This is actually in amps. So if I put in milliamps, I'll stick to amps for this one. This will work just fine. So right now we're going to do our 0, reading. Even though they're kind of oscillating a little bit, we are still going to say it's 0 at this point. So we got 0 volts and 0 amps. So there's 2 pieces of data that we're going to take, and I'm going to keep track of it for you as well. So we're going to take data even before the light bulb lights up. So we're going to see what happens before the light bulb lights up. We're going to take some qualitative data. I'll talk about like, oh, is it hot or cold or whatever. And then we're going to notice at which point does this either, we'll get to our maximum voltage point for the voltage source, or something will happen to the light bulb. So let's just see how this goes. All right, let's go ahead and start taking data. And of course, data is going to be in black pen because I'm a good scientist. All right, I'm going to do some like 0.25 volt intervals so we can get some good data. Okay, let's get this going. All right, we have a voltage. All right, 2.25 volts, and we got 0.03 amps. So 0.25 volts, 0.03 amps. And yes, it will be this exciting the whole way through. All right, let's do some more. And the light is not on yet, so we're going to keep going. Okay, we have 0.5 volts and 0.05 amps. Light is still not on. I wonder when it's going to turn on. This has never been so exciting. Blah, blah, blah. Okay. This is the hardest part, just getting that number to where I want it to be. Okay, close enough. So this is 0.75 volts, and we have 0.05 amps. Okay, let's see what happens when we get to 1 volt. Oh, look, you see it? It's glowing. Okay, we got 1 volt and 0.06 amps. So let's say 0.105. If you really must. Okay, let's keep on going. So we're going to go until either we get to the top of the voltage source or we get to where the light no longer functions. Okay. All right, we got 1.2. Oh, I forgot to make a note. So at 1 volt, the light turned on. Okay, at 1.25, we get 0.07 amps. Okay, let's keep on trucking. All right, we got 1.5, 1.51. We've got 0.08. Excellent. So we're going to keep on going. Okay, 1.75. 0. I'm going to call that 0.9. If you can't see, I'm actually fiddling with the knob. Let's say 0.08. It's staying at 0.08, the most consistent. Okay. Wow, that was fascinating. By the way, it's not warm yet. So I'm going to write that down. Not warm yet. I'm sure you're finding this just so fascinating. It's fine. Okay. We are at 2 volts. And it is 0.09 amps. Okay, let's keep going. Okay, 2.25 volts, and we're at 0.10 amps. Still pretty cool, but it's getting brighter for sure. All right, let's keep on going. This is exciting. We're turning on a light bulb. Woo. All right. .5 volts. And we got, oh, it went down to 0.09. Oh, no, it's staying at like 1.10. Okay. Do 2.75. Okay. That's close enough. 0.10. All right, let's go for 3. It's getting very bright. Like all of your guys' future. Oh, too real. All right, 3.0 volts, 0.10. Now, if you're like, Miss Shreve, slow down. I got the notes for you. I'll type them up, I'll post them, you're good to go. We have to get through this video first. Haha, suckers. All right, let's do 3.25. All right, I'm still having 0.10. Let me see. Okay. I'm not concerned if you're not concerned. There you go, something happened. All right, 3.5, we had 0.11. There we go. Okay, let's go for 3.75. For some reason, I'm picturing people just sitting there with like bated breath going like, what's gonna happen next? And I don't know why, but I find that fascinating. 3.75, 0.11. Okay, I need to make my table a little bit bigger. This is a lot of data points. It is getting rather warm, I'll be honest. So we'll see how this keeps going. This light bulb, she's bright, it's fine. Okay, we're going for 4. Okay, we got 4 volts. Ooh, look at that. That is oddly satisfying. So 4 volts is 0.12 amps. Okay, let's keep going. Live life on the edge. Now, if you can't actually see this, but my voltage source is like on the edge of its seat. So it only goes up to 6 volts. So see if anything interesting happens before 6 volts. Okay. Oh, it's bright. All right, we got 4.25. I got my overshot just a little bit. Life is hard when you're me. Okay, I got 0.13 amps. Okay, let's do 4.5. Oh, I'm sorry, I forgot to mention this like 10 data points ago. The negative just means that I switched the leads. That's my bad. It's okay. Look at that bright light bulb. Science is amazing. 4.50 amps. Oh, sorry, 4.50 volts and then 1.13 amps. Let's keep going. All right, 4.75 volts and I got 1.13 amps again. Let's keep going. Let's go crazy. Let's go to 5 volts. So we got 5.01 volts, 0.14 amps. Let's keep going. Okay, we're almost at the top of my voltage source. 5.25 and 0.13. All right, let's go 5.5. It is really bright. Like, honestly, it's hard to look at, not through a screen. Look how illuminated everything is. Okay, 5.5. We got 0.14. Okay, let's keep going. We're almost at the top of my voltage source. This is crazy. And I'm sure you're like, Ms. Shreve, it's not that crazy. You know what? These are wild times. Okay, let's go 6. So 5.78 was 0.14. Again, I'll show you the data at the end of the video. Oh, I'm nervous. Okay, 6.03 volts is 0.15 amps. Okay, let's keep going. Let's see how far we can go. Okay, 6.25 is 0.15 again. There's full 6.5. Oh my God. All right, this light bulb is stronger than my voltage source. So I'll tell you right now, it is very toasty. So that's a strong light bulb, man. Oh, yes, I actually chose the stronger ones. So there's actually 2 light bulbs I could have done with this. So you guys got to see the one that actually works. Isn't that just so lucky? Okay, let's take one last data point because that's the top of my voltage source. So the data point at the top, we're going to have 1.15 and 6.46 volts. Okay, now just for you guys, I'm going to go ahead and turn this off. All right, here is my data. There will be an image attached to this so that you can see it better. So what you're going to do next is you're going to graph this data for part 2 and determine by looking at the graph, is this ohmic or non-ohmic? So one thing I want to mention is that an ohmic graph is based on the equation V equals IR, okay? So if this is my graph, sorry, I moved my camera. So this is my graph. So here is basically V and here's R, okay? Or in our case, it's actually going to be I. Do it that way, I think. So if it's ohmic, it should look like that, which means you have a constant resistance. So I want you to graph this data and see if it's ohmic or not, okay? All right, thanks for putting up with my crazy. If you have any questions, please email either myself or your teacher. Have a great day.